stable, because once you have nothing but a null set, then that's what you have forevermore. It's just a null set. So there's no value and it doesn't go anywhere. So as a concept, yes, you can do that, but it doesn't produce anything. And actually, we can make a very similar argument with determinism. Determinism isn't that far off from a null set. It is a thing. It's not null, but it's all completely done already. So nothing changes. Can be no consciousness, can be no choice, can be no learning, can be no evolution, because all those things require, change. Can be no change. It just is. So when you have that, that's it. You got it. Nothing else. You see, it doesn't go anywhere. It's got absolutely no viability to do anything useful for anyone. It's not a viable kind of thing. It's like the null set. Yes, theoretically, null set's the simplest. And maybe determinism might be simple too, but it's without value.
Interestingly, this year's co-winner of the Nobel Prize, Sora Penrose, he apparently has joined the club, if I may say so, the club of people who scientists who don't believe that the Big Bang was all there was, that set of our universe, that there may have been an infinite number of Big Bangs preceding it and following it, a cyclical universe, as they call it, or a cyclical evolution of universes, to put it that way. What do you say to that? How would you comment on that idea that there's a cyclical universe and infinite number of Big Bangs forever and ever, so that evolution may go on and on?
Well, I think what physicists do is they eventually, when they dig deeper and deeper into the nature of reality, they get to the point that they know they don't have the whole answer. They know there has to be something else. That implicate order, that other thing has to be out there. Those hidden variables, that was an idea too. That there has to be something else going on to explain, because the materialist viewpoint just doesn't provide any answers to things like, where did that ball of plasma come from? Because there was no universe before that. So it didn't come from our universe. Then where did it come from? Space is expanding. What is it expanding to? How do you make new space? You see, they have all these paradoxes and things that they just can't answer. And they get to that point where they're against the wall and they just don't know. So they wave their hands in the air and they come up with something that, I think it's a cyclical thing, and it comes and it goes on, but try to pin them down to exactly how does that work? What's the mechanism there and how that works? And they don't know. It's just an idea. So that, I think, is physics with its back against the wall, can't come to any conclusions because its belief in materialism puts it in a space that doesn't have the answer. So they live in we call it like an answer space. Here are all these answers, but the space they've created for themselves in this answer space with the assumption of materialism doesn't contain the answers. So they're stuck. And they make up things like that. And we have another thing like that too, back against the wall sort of thing. And that is in order to explain these non-local events, these probabilistic events, particles don't exist, they're just probability, and then they appear where the measurement's taken, that sort of thing. It seems like there's all these possibilities that exist, and then the measurement somehow creates which one of those possibilities actually gets manifested as a physical thing. Okay, that's the way they think. So in order to keep that materialistic, then we have this idea of many worlds. Every time something changes, we have a whole new universe. You see, spins off another universe. Yeah. So, an electron flips from spin up to spin back or spin down. A whole new universe needs to start. I scratch my head with this hand instead of that hand. We have a whole new universe needs to start. And you can see 7.5 billion people all doing zillions of things besides scratching their head. And every tiny thing has to create an entire universe. Now, in each one of those universes, everything that changes in that universe
creates another universe,
spins off. Every action in that universe spins off. You know, it's got the same 7.5 billion people in it. And every time one of them spits, a whole new universe has to occur to where they spit and where they didn't spit. And the problem with it, you know, I mean, that sounds ridiculous, right? Because every one they spin off with all this interaction spins off that many more. So every one becomes a source, just like the original.
Just a technical term, you're talking about the many worlds interpretation of quantum mechanics.
Yeah, right, the many worlds. Yeah. So it's because the back's against the wall. They don't know how to answer this. So they say, well, if you had all these universes, then really, it really is all materialistic. We're just jumping from one of these material universes to another. And in this one, the particle's here, and in that one, the particle's there, and the particle is actually in all those places, and we just skip around in the various universes. Yeah, well, that is irrational, and it's not practical. But I will give them it's possible, you know, or I can put it, it's theoretically possible. In other words, it does do the job of keeping their quantum mechanics materialistic, but it does it at the price of being silly. Yeah.
To fill in our audience, I think we need to mention superposition, which is one of the main tenets of quantum mechanics. Like everything, you call it a probability distribution. Mm-hmm. So far, they use the term superposition. Things are in multiple states at the same time, and then the measurement creates a certain outcome, which was amongst that infinite number of possibilities would have been possible, but only it's the reason that the measurement is taking which manifests this particular outcome. Just to fill in our audience. Sorry to interrupt, but you know.
Yeah, that's a basic tenet of quantum mechanics. Now, of course, quantum mechanics has evolved to be a good science, and it's very accurate in its calculations. So it's good science, but it's just, as Feynman said, you know, shut up. You know, do the math. You know, calculate. Shut up and calculate. It's not a rational science. It's a mathematical. It's a calculation. So they know how to calculate if they start those calculations with the assumptions of, you know, particles are probability distributions. They're distributed. Yes, they're everywhere, but nowhere. They're just possibilities. And if you start with that as in your mathematics, that's what your wave function is. The wave function is a probability function. It's not a wave that's moving through some medium. It's just a probability function. So yes, that's the fundamental thing in quantum physics. And in quantum physics, you have these odd things that happen that defy materialistic logic. Like in the double slit, you know, experiment, the fact that when you look and make the measurement, it creates a particle there. Or in a double slit where there is a delayed erasure, that is, you start the experiment, particle goes through one of the slits or the other, and you measure which slit it goes through. Now you've measured it, so you should just get a pile of particles behind each slit because you've measured it. Well, then the particle hits the screen, goes through the slits, hits the screen, and the experiment's over, but the information of which slit it went through is still there. And if you erase it, if you delete it, you erase it and say, all right, we don't have that information anymore. I knew which slit it went through, but I erased it before I looked at it. What happens? You get a
diffraction pattern.
You get a diffraction pattern or an interference pattern.
We're not talking about the experiment that you're setting up and that you're allowed to set up because of the weaknesses of the original double slit experiment, right? I'm sorry to interrupt.
So that kind of a delayed erasure experiment, which means you erase the which way data. That's which slit did it go through. You erase the which way data after the experiment basically is over, after the particle has already hit the screen and found a position on that screen which can't change. But depending on what you do after the experiment's over, the experiment is different. That's a delayed erasure. So that just blows a big hole in a materialistic account of that. That just doesn't work. But because of this non-locality, things aren't local, things can be elsewhere. You have this many worlds theory that lets you jump from one of these many worlds to another, and that then supplies the magic of how things disappear and appear, in probability. But it's not viable idea. It just costs too much, as far as pretty soon you have trillions of trillions of trillions of trillions of trillions of universes, and that many again every microsecond, and each one of those creating that many again every microsecond.
Which is a pointless process. I mean, there's no evolution there. If you just create as many outcomes as possible, it's just equal to saying, well, let's not play at all.
That's it. See, that's the point. It supports materialism because it supports determinism. See, everything's done. All the possibilities are done in these many worlds. Many worlds cover all possibilities. So now everything's determined. There's no change. The change is an illusion because we hop through these various pieces of these other reality frames, and that's what gives us the illusion of time and the illusion of choice and the illusion of consciousness, is we're really hopping through all these frames. But you see, that is a circular argument. In order to hop through the frames, you need to hop. Well, you can't hop without time. Now I'm here, now I'm there. So you require time to make a hop to define time. That's not good logic. You see, it just doesn't work out well. So determinism and materialism just have a lot of holes in them. And, back in the early 1920s, the Born and Heisenberg and Max Planck and Schrodinger and, that whole crew, they were so excited about the idea that we've busted materialism and we have a whole new world out there. Physics has just had this tremendous breakthrough about the nature of reality, so different than we thought. Wow. And 20 years later, not so wow anymore, because everybody just got sore heads banging their head against that door trying to come up with some explanation. And that's because those guys were really, really bright. These were really a bunch of smart guys that did this, but they didn't have the concept of virtual reality back in the 1920s. We didn't have the concept of a computer, much less one, that could, Well, I think at that time, not of any kind of a computer. I don't know, maybe they had an abacus or something that you might call a computer, but we didn't have a general purpose kind of computer. Digital computing was just not even a wild idea back at that time. And until you understand that this is a virtual reality, then you can't see the logic in that, of why it's that way. So those guys knew something big was up, but they had not the concept to understand it. And now we have the concept to understand it. But by now, people have gotten so used to the idea that, materialism and determinism, that's the answer. Many worlds, well, that'll solve the problem, even if it is ridiculous as far as application goes. And it's just weird science. So we're kind of stuck in this position of having given up and accepting something that is not very logical at all in order to maintain our belief in materialism.
So if I get you right, and to let our audience catch up once more, you're addressing some of the weaknesses of the original double-slit experiment. First of all, beginning with the fact that it started out with what's called feeble light, not even single photons, like single dots of light, but feeble light. Do you want to comment on that?
Well, feeble light is a way, to do if you put a light beam and do an experiment, with a beam of light, that's called optics. When you do experiments with single photons, that's called quantum mechanics. That's the difference.